Okay, so that actually introduces a real universal constant. That's my velocity magnitude is equal to a global constant lambda divided by square root of x squared plus y squared. And now if I plug it in, the solution for this source, this isolated source, is going to be u is equal to lambda times x divided by square root of x squared plus y squared, and v is equal to lambda times y divided by the square root of x squared and the y plus y squared. Now this is going to be a solution that satisfies mass conservation because we can check, right? We can check what is the derivative of u with respect to x, what is the derivative of v with respect to y. The derivative of u with respect to x is going to be what? It's going to be lambda times 1 over square root of x squared plus y squared. So that's differentiating the numerator with respect to x. And then we also have to differentiate the denominator with respect to x. And that is going to give us, if you go through all the mathematics, it's going to give us minus x squared, right? Because x is preserved. And then you have to take derivative of the denominator, which is x squared plus y squared. The derivative of this with respect to x is 2x. So we have a 2x. And then the square root, we get a half. So that cancels. That's going to be divided by x squared plus y squared to the 3/2 power. Okay, so that's the x derivative with x derivative of u. The y derivative of v is very similar. So we get 1 over square root of x squared plus y squared, and we get a subtraction of y squared, x squared plus y squared over 3/2. If you add them together, so the divergence of velocity, which is the sum of these two terms, is going to be lambda, right? Is going to be, let's see, it's going to be lambda times the sum of the first terms, which looks like it's going to be 2 over square root of x squared plus y squared. And the sum of the second term is we have x squared plus y squared, which is going to be minus x squared plus y squared. And we are dividing by x squared plus y squared to the 3/2 power. Right, so the x squared plus y squared cancels with one of these powers, and we basically get back to this. But I think I'm missing a factor of 2 somewhere. Can anybody spot where I'm missing here? Yeah, so the problem is that I should get a divergence of v equal to what? I should get a divergence of velocity equal to 0, right? In order to satisfy the mass conservation equation. And what I got is it seems that the minus term only cancels with half of the plus term. So there is a factor of 2 missing either in the first term or in the second term. All right. So let me go back and fix the issue here. So the issue is the following. The magnitude of the velocity is proportional to 1 over r, right? But in order for the magnitude to work, the magnitude of the velocity, basically the magnitude of the vector velocity is equal to square root of u squared plus v squared. Okay, and that if you plug in these psi times x and psi times y, what we get is square root of psi squared times x squared plus y squared, right? So if you factor it out, it's equal to psi times the square root of x squared plus y squared. And that has to be proportional to 1 over r. So if the magnitude of the velocity is proportional to 1 over r, then the multiplying term, psi, has to be proportional to 1 over r squared for the magnitude of the velocity to work, right? So that's why the multiplying term should not be proportional to just the 1 over r, but proportional to 1 over r squared, and the square root has to be removed. Now, once you remove the square root, here's what we get. U should be lambda times x divided by x squared plus y squared, and v should be lambda times y divided by x squared times y squared. So if the derivative, if the square root goes away, what we have is instead of a power of 3/2, we get a minus x squared plus y squared squared over here, and the factor of 2 is preserved, right? Because the derivative of 1 over r is minus 1 over r squared. So we have a square over here, and then differentiating x squared plus y squared with respect to x, we get 2x. So that means by fixing the proportion, fixing the denominator, we are getting a divergence of velocity equal to 0.